Hello everybody, my name is Dr. Jan Janechka and I teach a bioinformatics class at Duquesne University, and this particular tutorial follows along one of my in-class assignments where I show students the benefits and advantages of R in RStudio, and I do this by having them import a data file that has a table with information on the human genome, which is the size of the chromosomes, how many genes are on different chromosomes, and some other information. And then what we're going to do is once we import that file into a data frame, we're going to get a summary of the table that's in there, of the different columns. We're going to get a total for one of the columns, and then we're going to make a simple bar plot. And while we're doing this, we're going to basically save the different functions and commands that we're passing to R through RStudio, and a lot of it's going to be through the menu, right? Because when we basically select a menu item in RStudio, it's basically passing the command to R. We're going to save that into a file that's going to become a script, an R script. An R script is simply a flat text file that has specific commands that are recognized by R. Okay, we're going to save that. And then I'm going to show how you can easily modify that particular file and then rerun it by sourcing it so that you can perform the same analysis on a different data set, for example. The other advantages of R in this R environment is that as you save your functions and commands, as you work on them, you're basically able to keep a record of what you did. So that a lot of times what we do is we perform some kind of statistical analysis or data exploration, and then often once we get some preliminary data and preliminary conclusions, a lot of times we put that aside. We may not work on the data set for a couple months, sometimes more than a year, and then we come back to it. And if we have that R script, we'll know exactly what we did, and we can basically redo all those different steps, and then we can also add additional statistical tests or other modifications to that particular data analysis. So that's one of the really beautiful things about R and RStudio. Okay, so let's go ahead and start. So what we're going to do is we're going to first download the tab delimited text file that's a table with information on the human genome. And now when you download a file that you're going to then import into RStudio, it's important that you actually save that data file, right? So if you were to, for example, click on it, like here I click on this data file, human-genome- it's called human-genome-info-clean.txt. When I click on it, it basically is opened up as an HTML document, right? So we don't want that. We actually want to download it. So to do that, we right-click it, save link as, and then we're going to download it to the folder that is going to be our working directory, right? And now we're going to go to our RStudio session, okay? And first thing we're going to do is we're going to set the working directory, right? So again, one of the main problems that we have, and that people who haven't used R before, they have when they start working with it, is that when they try to import a file, R can't find the file, right? So the best thing to do and make sure that you're in the right folder is to set your working directory by going to Session, Set Working Directory, Choose Directory. Now in R, the word directory is synonymous to folder. Okay, so I'm going to go to my folder that has the data file I'm going to import. And notice that in the lower right panel, you can see that the file we downloaded is in that particular folder. Okay, now another thing I want you to see is that when, again, I selected that command through this RStudio menu, notice that in the console, it actually passed a line of code to R, right? And so it sent basically by selecting those menu options, what RStudio doing is it's passing, well, if you select those specific ones, the command set WD and in parentheses the file path to the directory that I want to set as the working directory, and so it passed this function to R. Okay, so now what we're going to do is we're going to capture that function that was passed to R. So we're going to do this by creating a new script. So we're going to go to File, New File, R script, and we're going to copy paste that command to the top of the actual R script. Okay, and we're going to save that file in that working directory. I just want to make sure that I have the right file name. So in my assignment, I had the name of the file is lesson-2-exercise-your name. So I'm just going to put Janečka, my last name, and then hit save. Right? And now it obviously, if we look at the folder, it automatically saved it as a $R extension because we created a R script file, right? So it's in there. It also appears if we go down to that lower panel and we hit refresh, that file is going to appear in this Explorer window down here as well. Okay? And so one of the really nice things about writing these scripts is that you can actually add comments, right? So everything in the actual script that you have has to be something that's recognized by R. So it has to have the correct syntax, it has to have the correct functions, and so forth. However, you can add comments to yourself by just putting a # in the beginning of a line, right? And so you should really do this for every bit of code or command that you have so that you can keep track of what each of these things mean. And so you can also give yourself notes on what the actual script is doing, right? So I'm just going to put a # and I'm going to write set working directory, right? Okay. So the next thing we're going to do now is we're going to import that tab delimited text file, right? Now, to do that, we're going to go to File, and then we're going to go to Import Dataset from Text Base, and we're going to find that text file and open it. Now, when you're importing it, you're going to get a little window. That's the Import Dataset window, and it's going to allow you to change the settings of how it's actually viewing or looking at that file and how that file is structured. So for this particular example, we're going to leave it as default. You do want to make sure, though, is that in this data frame window, that basically all of the column headings are in bold, okay, so that they're being recognized as the names of the actual vector that's going to be in each column, or the data that's in each column, and that basically each column is separate and independent of the other columns, right? So you can kind of scroll across to see what's in there. And so again, this data is information that I got from NCBI on the human genome. This is about 3 years old, but it has the chromosome name, the RefSeq identifier, a session number for that chromosome, the size in megabases, GC percentage, and then numbers of different kinds of genes on each of those particular chromosomes. So it's basically the gene content and some basic information on the human genome. So now we're going to hit import. Now, so notice when we hit import, there's actually 3 things that happen, okay? First, we'll look at the bottom in the console. Notice that when we hit import, RStudio, again, passed 2 commands to the R program, right? So the first line of the command, I'm going to copy and paste it into the R script, right? And I'm also going to delete this greater than sign in the space, okay, because we don't want that in there. And so the first command, what it did is it used the assignment operator to create an object called human.genome.info.clean, okay? And into that object, it basically dumped everything that was read using the read.delim data import function from the file that we imported, human-genome-info-clean-text, okay? And so that, of course, in front of that has the path to that particular file. Now notice when you're providing the name of a file and the path to R inside of a function, you have to have that in quotation marks. Right? And so basically, again, I'm going to add a comment to describe what that particular line did. So it created an object that is the data frame of the table that we imported. Right? Now, below that, there's another command that was entered in the console. This is the view and then the name of the data frame inside the parentheses, right? And so this particular view command is basically asking R to open up a data viewer, right? And the data viewer is this window right here, right? So this is a viewer that shows the table of what you imported into that particular data frame, right? And again, the data frame has basically been assigned to the object that you specify here, right? And so basically the name of that object when you do the data import, that simply comes from the name of the text file that you're importing. And then finally, the last thing I want to highlight during this command, if we go to the global environment panel, so the upper right panel, you'll see all of a sudden a category called data appears. And in that particular data category, we again have the name of the data frame that was imported, and we have some basic information that has 24 observations of 12 variables. And if we click on it, we'll actually see this little arrow right here. We'll see the structure and type of each of those particular columns that are in there, right? I'm not going to go into that right now. Now, so let's add a comment for the view function. And so what basically that one did is it just opened a data viewer of the data frame that was imported. Okay? Now, I also want to highlight, notice that if we look at the name of that script, currently it's red and there's a little asterisk there. So that means, you know, you made some modifications that have not been saved. Once we save that script, it turns black, right? And this is kind of so that you can keep track whether or not you recently saved the particular file, okay? So now what we're going to do is we're going to get some simple basic summary of each of those particular columns, right? And so to do that, we're actually going to write the command that we're going to enter into the console below into our script. This has several different advantages versus writing it directly into the console or directly in the terminal of R. One is that when you're saving a R script file, that particular editor in RStudio is syntax aware. So basically, if you're making mistakes, because the R is very it's case sensitive. If you have any kind of spelling errors, or if you have the wrong number of commas or parentheses, it's going to basically create a line that is going to throw you errors, right? And so because this particular editor in RStudio, when you have the script open, is syntax aware, it's going to give you clues and make sure that you are correcting or you're correctly entering and writing that particular command, okay? And so what we're going to do is I'm going to first create a comment, and I'm going to write the comment is we're going to write a function that gets the summary of the data of each column, okay? And there's a very simple command to do that, and that's simply summary. Notice also when you start writing the function of a command in the R script, it gives you all the functions that basically have that start with the same letters that you're typing. So that again allows you to make sure that you're writing and spelling the command function in the right way. And if you hover over it, it even tells you what that particular function does, right? And if you actually, to save time, if especially it's a longer function, you can just click on it. It's going to fill in the rest of it, right? And then you basically, in R, your function format is that you have the name of the function and then parentheses. In the parentheses, you put in the different variables. So usually you have to specify what that function is acting on, right? And so that's going to be on the object human genome info clean, which is the data frame, right? And if you've correctly entered and spelled your particular data frame and the object, then you're gonna, as you can see, the RStudio does a sort of autofill, right? So the rest of the name appears. Okay, so now in order to pass that function into the console, I'm just gonna copy and then paste it below, okay? There we go. And so here's a summary of each of those columns, right? And so we're going to focus on the ones that have integers. So for example, the protein has the mean number of proteins per chromosome is 4,714. The mean number of other RNA genes is 1,981. So there's a mean of 1,981 other RNA genes on each of the human chromosomes. The minimum is 311. The maximum is 4,457. And so forth. Notice that if we look at the genes and pseudogenes, there's about 4 times as many, well, maybe even less, but it's like a little bit more than 3 times as many genes as pseudogenes on any particular chromosome. So there's actually quite a lot of pseudogenes in the human genome. Okay, now let's say you wanted to get the total of a particular column, right? So let's say we want to find out how many genes there are in total in the human genome. So we would basically want to get the sum of this particular column gene for all of the particular chromosomes, right? So we have the 22 autosomal chromosome and then the X and the Y, right? And so in R, it's really easy to do that. So we, again, have a very simple function that does it. So it's sum. Now we're going to do a little bit of different, right? So we're still going to enter the name of the data frame that we want to perform this function on, right? So it would have the human, we're going to start typing human genome info clean. But now, in order to specify what column we want that particular function to sum up, we basically add a $, and then we add the name of the column, right? And so we would put gene. Now, in terms of R, each of those columns actually has a vector, right? So the name gene is the name of the vector that includes all the numbers of the genes on each of the chromosomes, right? And so I'm not going to get into the vectors right now. I'm just going to discuss it as the sum of a column, right? So we're not going to get into the different kinds of data that R is working on. We're going to talk about that in some other videos later on. Okay, so again, we want to add a comment that explains what this function is doing. So this is getting the sum total of basically integers in the column with the number of genes, right? So this would be, I'm going to put i.e. total number of genes in genome, okay? And so when we again copy that actual line, paste it into the console and execute it, right, we get 54,099, right? So basically there's about, that's similar number, like they have recently updated it. So if you look at the same table now in NCBI, so again, this data table is probably about 3 years old. There's been slight modifications to this because some of these genes have, been updated. There's some genes are added, some genes are removed. There's constantly annotation updates to the human genome, but it's still roughly the same, right? So that's includes both protein coding genes and other types of genes, like the RNA genes and so forth. Now finally, I'm going to show you how to do a real quick plot, okay? So we're going to basically create a bar plot, and so for a bar plot, we're going to use the simple bar plot function, okay? Actually going to keep it on one line. And then in that bar plot function, again, first thing we're going to put in is the name of the data frame that we're actually going to run it on. We're going to then, again, because we want to make the bar plot on, we're plotting the number of genes per chromosome, right? So again, we want to basically add the data frame, the name of the data frame, and then the $, and the name of the column that we want to plot, right? Now, so that we can modify how that particular plot looks, we're going to add additional arguments, right, or variables to that particular function, and we're going to do those by separating them with a comma. So we're going to add a comma. The first argument we're going to have is an argument that's going to specify and tell R to add the names of the different chromosomes under each of the respective bars, right? And so to do that, we're going to add names.arg equals, and then again, we're going to pull from the name of the column that's called name, right? Because that has the name of the particular chromosome, okay? We're going to then add another variable, main. This is going to add a title to the actual bar plot. So we're going to call numbers, I'm going to call it numbers of genes. I'm going to keep it lowercase, genes lowercase. And then we're going to add a label for the x-axis, so x-lab. And we're going to label that with chromosome. So the x-axis is going to be the chromosomes. Now, when you have a function, you can actually run that function across multiple lines. So to do that, you just hit a return, right? So we're going to hit return, and we're going to put the rest of that function on the next line. So that's okay to do. And so let's see, X labels chromosome. We're going to add a Y label. And the Y label is going to be number. Now, we got to make sure when you're putting in text for labeling things, that also has to be in quotation marks. So actually, I have to go back to the X label and put the chromosome into quotation marks. Okay, there we go. Now we have, yeah, that looks correct. Okay, now I also want to show you again how RStudio, the editor, when you're writing the script, is syntax aware. So for example, what if we left out one of the parentheses, right? Notice what happens, right? You have a little error mark on line 11, right? It's on line 11 because this is all one command. It's just scrolling over to line 12, right? And if we end up putting that parentheses back, right, that error disappears. Now the next thing we're going to do is we want to save that bar plot as a PDF, okay? And to do that, we're going to use the def print command. So dev.print. And within that, the def print command basically saves the current plot into a file, right? And so the first variable we're going to put in is the name of the file. It's going to get saved into the working directory. We just call it figure1 dash genes dash p or period PDF. Okay. Notice again it's in quotation marks. And with that def print command function, you can actually have it save in several different formats, right? And so we're going to specify what format it's going to be saved in with the device argument. So we're going to do device equals PDF, okay? And then finally, we're going to specify the width and height of the actual PDF figure, right? So width is going to be 8 and height is going to be 8. Now, one thing with when you're entering a function, whether you have a space after the commas, for example, or after the equal signs, it doesn't matter. You know, like if you were to run this, you'd get the same result as if you had no commas in there. However, you basically want to stick to the common convention, right? So you want your code that you're writing to follow the standard syntax and format of, you know, typical R users, right? So typically what you do is you do not include a space before a comma, you do include a space after the comma, and it makes the code more readable. Okay, and so again, we're gonna add a, I'm gonna correct the spelling there. We're gonna add a comment. So, you know, this is line 12 is gonna be make a bar plot of genes per chromosome, right? And then above line 14, we're going to add a comment that's going to be save plot as PDF, okay? All right, now we're gonna save this, all right? And we're going to now enter, we're gonna copy these two. And so what we could do is we can copy, paste them into the console, right? Or you can also actually use this little icon here that says run, right? So if you select some rows, or I'm sorry, some lines, and then you hit run, they're going to get run in the console, right? And so R ran those, and notice that you end up seeing a plot appear on the lower right hand side in the plots panel, okay? So that's the number of genes per chromosome. Now notice that the number of genes goes down as the chromosome name or number goes up, right? And this is actually something that makes a lot of sense, right? So when the human chromosomes were named, they were named based on their size in the human karyotype, right? And so the human karyotype is organized from biggest to smallest, right? And so the smallest chromosome was, I'm sorry, the largest chromosome was named 1, and the smaller ones were basically named, you know, 1 through 22, right? And so as you go down in chromosome length, you naturally have less number of genes in general, right? Now there's some chromosomes that are more gene dense, and there's other chromosomes that are not as gene dense, right? So it isn't necessarily a perfect pattern, but the trend is definitely there. Okay, so we're going to save our script, which I already saved it. Now, what I want to show you is that if you, let's see, if you refresh this little file explorer, you'll notice that the PDF also appears in the working directory, right? So again, that was saved due to that def print command, right? So when we click on it, it's again a, you know, regular straight up PDF. So here we go, it's already opening. It's just a little, there's a little lag time there, right? So it's a regular PDF. Now, if you go into the bar plot function, you know, there's a lot of other things that you can do to change the appearance of this particular figure. There's also additional R libraries such as ggplot that give you much better control, and they can make much nicer, aesthetically pleasing figures, much nicer figures. But the bar plot actually makes it, you know, it makes a really nice figure. Okay, so now let's say that you wanted to redo this sort of like this flow through, but you wanted to do it for a different column, right? So let's say pseudogenes, right? And so, you know, you could do this by retyping everything, right? But again, one of the really nice things about R and RStudio, it allows you to automate things and make things much simpler and allow you to work much more efficiently, right? So what we're going to do is now we're going to save this script as a lesson -2 exercise Janečka but now we're going to call it pseudogene. Okay, pseudogenes, save. And so again, notice that if we refresh it, it appears here, right? We're going to open this. Well, actually, we don't have to open it because we did save as, so it's right there. But so now what we're going to do is, instead of getting the sum total of the gene, we're going to get the sum total of the pseudogenes, right? And so we're going to go through this script, and we're going to replace, whenever we're making a reference to the gene column, which again is a vector of integers, we're going to replace that name with the name of the vector or the column that has the pseudogenes, right? And so then you got to make sure that the spelling and format in terms of capitalization is identical as in the name of that particular column, right? And so we're gonna, let's see, so pseudogene, so it's singular, and it has a capital P. And so again, I'm gonna replace gene with pseudogene in the sum command, right? Let's see, it's spelled correctly. And I'm just gonna actually copy, just make it easier, so I'm not copy paste over the name, right? And so then I'm gonna, in the bar plot, I am gonna replace gene with pseudogene. The name, the name or the name of the chromosome below each bar plot is gonna be the same, right? So this particular argument, names.arg, we don't have to change. The title of the figure, we're gonna want to change from genes to pseudogenes, right? So it's gonna be pseudo. And the X label, we're gonna want to keep the same, but the Y label, we're also gonna keep this is generic, it says number, right? The very last thing we're gonna change is the title of figure 1. We're gonna just call this figure 1 pseudogenes, okay? And then we're gonna save it, right? Now, what I want you to do is go ahead and close the script, right? So we're closing the script. We're closing the data viewer, okay? We're actually going to remove this data frame from the global environment. So to remove an object or a data frame, we would just do rm and then the name of the object, okay? So notice that doesn't appear there anymore, right? And now what we're going to do is we're gonna source this script, right? And in order to do that, we're gonna use the source function. So we're gonna write source parentheses, and we're gonna put the name of the file. Now remember, when you put in names of files, it has to be in quotation marks, right? So we're gonna write lesson dash 2 dash exercise dash Janeczka dash pseudogenes dash R, okay? We're gonna add another variable in there, which is gonna be echo equals true, right? And so this is gonna make sure that when R is running through the script and different commands, they're gonna show up in the display buffer, right? So if you didn't do that, for example, when you do sum, the pseudogene column, you get that value. If you don't have echo true, that part's actually not being saved. Now you can easily have it output to a file, but the default is that in R, whatever runs through the display buffer, it's not being saved unless you tell R specifically to save it, right? And so we're gonna get that echo equals true. Hit enter. All right, so see what happens. So we executed that script by sourcing it, right? We ended up that data was re-imported and it appears as a data frame. If we look to see the viewer got opened up again, right? So now we have the data viewer. If we look at the number, so the total number of pseudogenes is 16,001. So again, that's about a third of the normal genes, or functional genes, just to say. And then we also have the pseudogene barplot, right? If we go to our files and then we refresh the folder, we can see that the PDF also appears there, right? And if we open it up, again, it's just a PDF like it was before, right? Another thing I want to point out is if you are in the same session, right, you go to plots, R does actually save the plots as you go through them, right? So if you hit this little back arrow, you can actually list through the plots that you have recently executed. Okay. However, again, if you want to save a plot, you got to make sure that you do some kind of function to save it. So you could, instead of saving it through a command, you can also export it here, right? So you can do save as PDF just through the menu as well, right? So it's another potential option. One thing I do want to point out is that I had some students, when they started working on this in-class assignment, they closed RStudio and then they opened it back up and they were getting errors basically. And so often what happens is that if you close your R session and reopen it, okay, what's going to happen is that you're going to, first of all, potentially no longer be in the working directory where your file is that you're trying to import. Another thing that's going to happen is that your data frame is not saved in the global environment normally, right? So if you want to basically, like, let's say if you're halfway done, right, you save where you're at, you save that session, and then you want to go through and you want to finish where you are, finish that particular script, or finish the set of commands. You basically want to make sure that you re-import the data file and that you basically run the commands that created objects in your particular R session, right? So otherwise, when you type the name of an object, it's not going to be there, right? Or you're going to get an error because R will not recognize it, right? So you got to make sure you do that. So again, if you're having trouble because you basically quit a project or session, reopened it, the two most common solutions to the most common problems that I've seen is that make sure you're in the right working directory, make sure that your data is imported and appears in the global environment. If it's not, then just re-import it, and make sure that the objects that you define in that previous session are again defined in the new session that you have. And again, if you're saving all your functions and all your commands in that particular script, it's really easy to just re-execute those, right? And again, I think this shows a nice overview of how rapidly you can make a script. You can do something that's executable, right? You can save your work, and then you can easily modify what you're doing, to basically apply it to a different data set. If we wanted to, for example, run a linear regression on the number of genes versus chromosome size, for example, we could easily do that. We could add that to the script, and then we could perform that statistical test when we source that file. Okay, so I hope you guys found this informative, and again, we're going to be posting, or I'm going to be posting more tutorials and videos as the semester goes on. Thank you very much for your attention, and I hope again that you found this useful.